All right, let's put this one to bed. So, I don't know if I actually showed this to you guys, but this here is our ultimate goal. And through all the trial and errors that I went through, I discovered, so this began life. This is where we're going to go first. I discovered that, contrary to what I started out as a scatter plot, and then see how this axis, I couldn't get the titles, like the elements that are down there, right? So eventually I learned the way to get titles was to turn it into a line plot. Oops. And I do see something. Now this one here, the other hard part though was there's no grid line that goes through, but I now notice that each one of these, that's one material, that's the other material. So this would work. And this is our ultimate goal here. So take note, all this formatting, the legend, the title, right? But I would say is you want to make both of these, because what this one is let's see. Actually, I don't think it's right. So we reset this. So now you see how that I auto scaled. You know, if I make this one, this is where this one on the left is where you guys are at from the last video. So let's make them as close as we can. And yeah, see, from 0 to 1.00 times 10 to the negative 2. And you see they look pretty similar. I see where I can make those points smaller because we can't, I don't think we added the error bars yet to ours. And you can see error bars here. But I just wanted to show you that you want to have this plot, and then the other plot is here. This is zoomed in. And we're going to go over how to do that. Okay? All right, so let's get into it. I'll finish up dealing with this guy. And yes, I believe that it needs error bars. Now there's an arrow there. Oh, there's arrows on either end. Oh no, it just resembles an arrow because it's there's a data point there. Okay, now excuse me. Let's just see if there is. Oh, there is an error bar, but somehow, so they must just be invisible. But let's see that micrometer ruler. So they all have error bars. Okay, so I'm just going to, guess then I showed you the trick to pick it. So then the series, because if you just say insert error bar, it's going to put it on the accepted values as well. And why? So I see I haven't completely finished. All right, so we'll say custom, and which one are we doing? I don't remember now to check. Calipers. Okay, so here is the table where it's going to come from. Oops. If I select this, whoa, great. So specify value. So calipers. Okay, nice. So they're quite small. Let's see, so let's just go to error bars for the ruler and custom specify and ruler plus minus density for the ruler. And looking good. And then we need plus minus for the micrometer. Oh, we didn't even have to select it. It's in the drop-down box now. And micrometer. Okay, so now it has this. Nice, huh? Now let's see. We want grid lines here. How do we get those? Categories, axis position. All right. I don't know. I'm going to pause for a moment. Okay, so I see that I want axis grid lines. And for the Mac users, it would be up here, format, axis grid lines, horizontal axis. And I left it at automatic. Okay, so let's go take a look at our other guy that we weren't happy with. No, not that one. The one we've been working on here. All right, so value axis. So horizontal. So we have to actually insert them. Okay, no problem. Grid lines. Primary, major, horizontal, and somehow they disappeared. And let's hit the undo button for a minute. Okay. Now let's see, add grid lines, primary. You know why? This minor, major. Oh, vertical. I said horizontal. Bite my tongue. Yeah, of course, they're vertical grid lines. I'm thinking in terms of this horizontal axis. Okay, so let's go some other tricks. There's your legend. So to get that, you select it, add chart element. If you see how if you put it on the left, it's a pain in the ass to reformat. So it's best to just tell it to put it on the bottom, and then you'll see the grid lines can be seen through it. So you can just use your right mouse button. Oops. If I can get it reselected. So you can fill it with other thing. I'm going to just use white. And then you can simply increase the font here. Oops. And you see, if you miss and you drag the wrong thing, you just select again. Okay. Yeah, I like this feature. And it's here, see? Angle counterclockwise. I think that looks kind of cool. Here, and especially when you have something, it starts getting bigger. It's not that big of a deal here. It depends on, like, if you're using Synot, you have to decide. I just kind of think that looks cool. But now it takes up some more space, I suppose, vertically. It's about planning ahead. And notice this thing now, yeah, I've added the label to the left. And then how do you zoom in? So remember, we want two. We want this overall one, just to show all your data and the various choices you had of a known material. So don't forget, you need to add an axis label. And I would say you should do as much formatting on this one first. And then once you like it, you can then just go copy and paste. And everything you did is there. Now, some reason the legend came out a little differently. I don't know why. And then the legend can be done. You could also say, I don't know why I can't change. Oh, yeah, I have to go to Chart Tools. And alignment. Oh, how do I align that to the left? That shape. Well, here you go. Format legend. Text options. Here it is, I believe. Middle, center, horizontal line. Oh, that's the direction. There's vertical, up, down, left. I wanted to see if we could move it over to the left side. Well, somehow it won't let me, but I can just resize it as it will. If you give it like this, see it spaces out a little more. Notice it has the units. Well, see, the trick here is that each of the data series, I pick one of these boxes, right? So then if I change one of those boxes, it changes the legend. Pretty nifty, huh? Okay, so we've decided that we only care about what's happening in this narrow area here, but we'd like to include this dot. So it looks like 7.5. Let's try 7.5 to 9.5. Now, axis, I double-clicked it. So we want to go the vertical axis. We want to format that. Then there's this guy here. And so it's not in scientific notation, makes it a bit of a drag. But this is, let's see, 7.5 times 10 to the negative 3. We can write it on a piece of paper. And 0, 0, we can just see the 01 there. So it's 7.5. And you can see right away that it worked. And, so I thought I wanted 7.5 to the minus 3, I thought. And let's see. 1, 2, so it looks like I got to knock off a 0. Yeah, because see, on the left there, this blue dot, I don't want that one. So I did too many. So turn that into that. And I wanted this one to be, well, it seemed like it cooperated with me. I guess I said 7.5 and 9.5. Oh, I see, because it's picking the major unit of 2. See down here? So let's try 6. Just so it looks nicer. And these, yeah, I like that. Yeah, I'm liking that. Okay. And there you have it. And we still have, so I guess it looks like everybody's still on there. I thought there was one that was heavier. Let's take a look at this quickly. No, copper is the densest one. So now we can see all the error bars. And again, this is in my case. Now, one thing I noticed, I can't see all my data points, so I have to choose maybe a different place. Now I can see all the data points. Oh, no, excuse me. Those are the accepted ones. And you see here now, you can see the data point. And remember, this was the only one where the figure of merit we were looking for. It's the only one of all the measurements that has that figure of merit that's positive. And what the figure of merit positive means that the error bar is bigger than the difference between our measured value, which here is represented by the lines, and the error bar is bigger than the difference between our measurement and the accepted value. And so hopefully, I mean, the ideal situation would be that all three of your measurements are on top of each other. So all those lines are very close together. And okay, let's put it this way. I guess it would still be acceptable, this line for micrometer and this line for calipers, if they both fit within the error bar of the ruler, and then the really exquisitely beautiful result would be as if the micrometer fit within the error bar of the calipers, and then the calipers and micrometer together fit within the error bar of the ruler. That would be beautiful. And we can talk about more if people want to send me their spreadsheets. Because in this case, maybe we were discussing it in class where maybe some of the plus minuses on errors could have been better. But at the end of the day, I mean, we've learned a lot here, right? And we basically see, let's see, so with the calipers, it's kind of a toss-up where it could be brass or copper. Whereas the micrometer, we're going to say that we know. Oh, and by the way, I noticed that the colors of micrometer and ruler are probably too close together. I should pick a better color for the line there and the points. So it's especially if they were closer together. But just for FYI. All right, so remember now, we're going to be, let's see, what do we need in our final logbook? We have the two charts. And we have, I would say 1, 2, 3, 4. And you just explain one of them. Well, they're pretty straightforward, right? There's no error propagation going on here. This is just data. The only thing that's here is that we made the R calculation just to make our lives easier later on. Excuse me. And then I don't know what's the polite word for burping. Then there's this table. And let's think about this. Let me pause this for a minute. All right. Yeah, the whole reason I created this table down below here is, and that's new. I did a lot of head scratching on this analysis, like on Thursday, Friday, Saturday, and today, even Sunday. I've been really thinking about this, and this is what we've done in the past. And I kind of forgotten about something I will probably, you'll hear me say in class, that human beings process graphical data much better than they process tabular data. Just think of lions hiding in the grass, right? We see changes and we compare things. So we're much better at that kind of thing. So once again, I'll show you believe this is, completely formatted and zoomed in. I said here is 7 to 9.5. This one is 7.6 to 9.2. It's a matter of taste, I suppose. It meant that I had a nice clear space under here for the legend, whereas in this plot I moved the legend up here because, well, I could maybe put it down here on the lower right. But, and then in this case, the legend has a lot more room to be put where it needs to be. And so in this case, I decided to make a box around that. So I told it I wanted the outline here instead of leaving it with no outline. I think it draws the eye better. And I don't know if the bottom needs an axis label. I didn't put it because it's all implied, right? Plot of measured and known densities. So density accepted, maybe you change this to known densities and you put this here. Maybe you change the title to accepted. These are little nuances that you would go over as a group before you went out to do a presentation of the group's result. And, you don't have to tip it like this if you don't want to. Just ideas, right? Just looking ultimately for effort to make it look clean and neat and easily digestible. And, right, so if you went ahead and made these 3 tables here, I apologize. It's not going to kill you to have done them. You'll learn something. But ultimately, it's really not, I'm not going to require it. And to be, at least to put in, I'm going to ask you guys to submit your spreadsheets for sure, and I'm going to look them over. And then see how I've got this nicely cleaned up. It's got units, the plus minus, etc., etc. All right, so I'm going to start having this up onto YouTube, and we'll deal with questions as they come up.